In this video, we will discuss the problem aggressive cows. Let's read the problem statement. Problem says that you are given an array with unique elements of stalls which denotes the position of a stall. So basically the stall array that has been given, it is containing the positions where the stalls are situated. And you are also given another integer k, where k is the number of aggressive cows that have been given to you. Your task is to assign the stalls to the cows that have been given to you such that all the cows get placed inside and the minimum distance between any two cows is maximum possible. So let's try and understand this problem statement more clearly using the test case here. Suppose that we have this particular test case here. So you can see here that we have been given the stall array where one stall is standing at the position 1, another stall is at position 2, another stall is at position 4, another stall is at position 8, another stall is at position 9, and we have been given 3 cows here. Now notice one thing, that the stall positions that you will be given, the array might be sorted, it might not be sorted as well. So firstly, we should sort the given array. Why? Because when we will try to place the cows, so we should place the cows in a sequential manner. If the stalls are arranged in an increasing fashion, it will be easier for us to iterate and place the cows one by one as per the requirement. Now if you will see here, the k value has been given to us as 3. So we have total of 3 cows. Okay, so maybe what we could have done is we could have placed one cow, let's say C1 here. Let's say another cow could have been placed here. Another cow could have been placed here. So it's like you can say that if I place C1 cow at this index and C2 cow here and C3 cow here, then what is the distance here? If you see, the distance between this C1 and C2 cow will be 1. The distance between C2 and C3 cow will be 2. Correct. And there will be one more distance that will be between C1 and C3, but that will be 3. We do not need to consider it because we are trying to find the minimum. So when you take the distance of the cows that are non-adjacent, the distance will be higher, so no need to check that. Now if you see here, the one of the distance is 1, another distance between the cows is 2. Now which one is the minimum? The minimum is 1 here. So we have to the minimum distance here comes out as 1. As of now, the minimum distance comes out as 1, but we have to try and find the maximum value for this minimum. Okay, we have to try and maximize the minimum distance between any two cows. Correct. So can we do something better? If you will see, let's write this test case again. We have got 1, 2, 4, 8 and 9. Okay, suppose that if we place C1 cow here, okay, and let us say that if we place the C2 cow here, and let us say that if we place the C3 cow here. Okay, right now if you will see, what is the distance between the cows? The distance between these two cows is basically 3, and the distance between these two cows is basically 4. So what is the minimum distance out of 3 and 4? The minimum is 3. So you can say that we can place the cows at a distance of 3 as well. Because the minimum distance is basically 3, so at least the distance between the cows is 3. It can be between some cows, it can be more than that also in the same adjustment. At least the cows are 3 distance away from each other. So right now you can see that I have increased my minimum value. I have increased the minimum distance between any two cows. So I have to try and find the maximum value of this minimum distance between any two cows such that I'm able to put all the k given cows inside the given positions. Okay, inside the given stalls here. Now let's see what we can do here. So one of the approaches can be that we can apply brute force here and we can try to solve this problem. Now how can we apply the brute force approach here? If you will see, one thing that we need to notice is, let's say we have been given the test case that was 1, 2, 4, 8, 9. So let's say we had the test case that is 1. Then after that we had 2, then we had 4, and then after that we had what? We had 8, and then we had 9, and the k value is 3. So we have to place 3 cows, remember this. Now what we can do is we can try to check, like, why am I saying that this will be linear search approach? Because I'll try to check, can I have minimum distance 1 between any two cows or not? Then if I can, then I'll try to check that can I have the minimum distance 2. Then after that I'll try to check, can I have the minimum distance 3? Then after that, if this is possible, I'll try to check, can I have the minimum distance 4 or not? So I'll linearly iterate and check for every distance, right? So that is why I'm saying that this will be a linear approach where I'll check for 1, 2, 3, like this. Now if you see here, like, I know one thing for sure, that the distance at least will be 1. Okay, the minimum distance will start from 1, but what is the highest value till which I should go? So you can see here that suppose there were only 2 cows. then one cow will be standing at the first index, another cow will be standing at the last index. The distance between these two will be 8 as per this test case here, right? So the minimum can go till 8. The distance between the cows can be 8. If there are only two cows, then the distance can be 8. So that is why we will take the we'll start the minimum from 1, and we will keep on iterating until the minimum fails. Okay, so until the minimum fails, this means that if we are not able to maintain that much minimum distance, then we'll stop. So if you will see here, let's see if we can maintain one distance or not. So we have to place three cows. Now suppose that if I place the cow 1 here, okay, then after that I place the cow 2 here. Can I place it? Yes, because the distance between these two is 1, so it is fine. Now after that, can I place the cow 3 here? Yes, I can. So because the distance between these two adjacent cows is more than 1, so it is completely fine. Correct. So this means that if I take the minimum value as 1, it is fine. If I take if I allow one distance between any two cows, that is acceptable, that can be possible in this test case. Okay, so we'll in the result variable we'll store this minimum, that is we'll store 1 here. Now after that, we'll try to increase the minimum value, and then we'll check for the next value, that is basically 2. So we'll try to check for 2. Does 2 satisfy the criteria or not? So when we'll check for 2, so initially my C1 cow will be here, first cow will be here. Now can I place the second cow at this place? Because if you see, previously the cow was placed at index 1. Can I place the next cow at the index 2? No, I can't, because the distance is 1. So I can and I need at least distance of 2. So I'll check at the next place. At the next place I have the element 4, so the stall is at the position 4. Now what is the distance between 4 and the previous stall? That is 1. If you see the distance, that is 3. So obviously it is greater than the minimum distance, so I can place the second cow here. So I'll place the second cow at this place. Now can I place the third cow at the position 8? Yes, I can, because the distance between 4 and 8 is 4. So that is why we can we need only two distance, at least two distance. So then we can place cows at 4 distance away from each other, because the minimum is 2. We require 2 distance, but these cows 4 and 8 have a distance of 4 between them, so it is completely fine. So this means that minimum 2 is also the answer. So result will get updated to 2 here. Now after this, what will happen is, next up my minimum will get updated, we'll check for the next value of minimum. So basically minimum will be 3. We'll check whether we can maintain a distance of 3 or not. So if you see here, initially my cow 1 will start from here, and always we'll start placing from the starting stall, so that we can have as much space as possible. Okay, so C1 cow will be placed here. Can I place the C2 cow here? No, because if I place the C2 cow here, the distance is 1, but I need at least 3 distance. So now I'll try to place the C2 cow at this particular place. Can I place it? Yes, because the distance between 1 and 4 is 3, and I needed at least 3 distance, which is completely fine as of now. Now after that, I'll try to place the C3 cow here. Can I do that? Yes, I can, because the distance between C2 and the distance between C2 and C3 is 4, and I needed the distance at least as 3, so this works fine. Now I can update the result as 3 here. Okay, because 3 is also satisfying the criteria. Now after that, the minimum will be equal to what? The minimum will be equal to 4. I'll check for 4 whether I can place the cows at 4 distance away from each other, at least 4 distance away from each other or not. Whether I can place 3 cows at least 4 distance away from each other. Now what will happen is, C1 cow will be placed here. Can I place the C2 cow here? No, I can't, because the distance is not big. Then after this, C2 will be here. Can I place the C2 cow here? No, because the distance is 3, but I need at least 4 distance, so I have to place the C2 cow further away. So C2 will be placed here. Can I place the C2 cow here? Yes, I can. Now you see that I can place the C2 cow here, because 1 and 8, they have a distance of 7, and I needed only maximum distance of 4. So I needed distance of 4, but the distance is 7, which is completely fine. Now can I place the third cow C3 at the position 9? No, because the distance is 1 only. So I'll try to go ahead. Now when I go ahead, I cannot place the C3 cow here. So this indicates that I cannot place 3 cows in the given stalls such that they are at least 4 distance away from each other. So that is why minimum is equal to 4. This fails, right? So 4 is not the answer here. If I cannot place the cows at least 4 distance away from each other, this means that I cannot place the cows 5 distance, 6 distance away. So I should break away, because if I cannot place at 4, I cannot place the cows at 5 distance, 6 distance, 7 distance away. So I'll have to stop here. Now what is the final result that we got? The result that we got was basically equal to 3 here. Why? The reason being, because 3 is the distance which was at which I was able to place the cows efficiently, such that every cow was placed inside the stalls without any cow being left out. If you see the time complexity, what is the time complexity here? So in the worst case, how much am I iterating? You can see that I'm iterating from 1 till 8. 8 is what? 8 is basically high minus, like you can say max minus min value. That is the maximum element of the array minus the minimum element of the array. So we are iterating from 1 till mx minus min. Okay, this is one thing. Now for one particular mid, understand one thing, that for one particular given mid, I'm iterating indirectly throughout this array. I'm iterating order of n times. So for one particular value, understand this thing, that for one particular value, I'm iterating for how much time? I'm iterating for order of n time because I'm iterating throughout the array. Okay. And how many minimums are there? For one minimum, I'm iterating throughout the array. So in the worst case, how many minimums I have to iterate? I have to iterate all of them. So in this case, you can say that max minus min is the number of iterations that I have to do, because 1, 2, 3, 4 up till max minus min. So this will take how much time? It will take n into max minus min time. So let me write this more clearly. So this will take nothing but for max minus min, because at worst I have to do these many iterations. I have to cover these many ranges, right? So this will be max minus min element of the array into n value. So you can see as of now the complexity is quadratic in nature. It is a brute force approach, and we applied linear search. Let's see the implementation as well of this linear search. Now if you see here, what we will do is, firstly, as I said, we will be sorting the given stalls. Why we are sorting the given stalls? The reason being because we will be iterating in the increasing order of the position of the stalls, so that we can place the cows efficiently, and we can check the distances easily. If the stalls are not sorted, it will be very difficult to find that I should keep a cow at which place, and randomly keeping the cows will not help me to find the distance efficiently. Now after this, we'll update the result initially as 0, and initially, as I said, the minimum distance will be 1 and the maximum will be the last element of the array minus the first element of the array. After this, what will happen is, of the sorted array, after this what will happen is, we'll iterate from 1 till the maximum distance. That is, we'll iterate from 1 till max element of the array minus the minimum element of the array. Okay, because we'll try for minimum as 1, then minimum as 2, minimum as 3, up till this last value. Then after this, we'll check. What we are going to check is, we're going to check that if that particular ith value of minimum satisfies or not. If the ith value of minimum satisfies, right, that if I can keep all the k cows at least I distance away from each other, then I'll update my result with it. Okay, and I'll keep on moving forward. I'll keep on checking for the next values of I, and at the end, you can see in this particular case also, when my result was 1 initially, then it became 2, then it became 3. After that, when I came to 4, 4 did not satisfy, so I broke away, because I could not maintain the minimum distance of 4. So if I could not maintain 4, so I cannot maintain bigger distances also. So that is why we can break away, and you can see result was storing this answer. So you can see here that at the end, the result will be storing the answer, so we'll be returning it. Now the main thing is the check function. How are we writing the check function? Remember that check function was iterating throughout the array to check for the allotment of the stalls to the cows. Now if you see here, what will happen is, initially we will be placing the very first cow at the 0th index stall, correct? So we'll update the count to 1, and we'll say that the previous stall that we have just used is basically the stall at the 0th index. So we'll store its position here. Then after this, we'll iterate starting from index 1 till the last stall, and we will check what? We will check that if the distance between the ith stall and the previous stall which was allocated to the previous cow, if the difference is greater or equal to the distance, that is the minimum that I'm considering right now, that is the I value that I'm considering right now, which I'm passing here. So in that case, we can say that we can allocate the cow this particular stall, and we'll increase the count that we have put one more cow at this particular stall, and now this ith stall will behave as our previous stall. And if we can allocate at least k cows or more than k cows with this minimum distance, then in that case we'll return true, that yes, it is possible that k cows can be arranged with that much distance here. Okay, so always we are checking what? As I said, we are just checking that if the ith stall minus the previous stall, that is the distance between the ith stall and the previous stall, if it is greater or equal to the minimum distance required, then I can place the current cow at the ith stall, and I can increase my counter that I have placed one more cow. And if I can place, suppose that they were asking me to place how much, like let's say the k value was 3, and for a particular value I was able to place 5 cows. If I'm able to place 5 cows, that is very good, like, but I needed 3. So at least if I'm able to place k cows, then I'll say that yes, I'll return true, and then that will be updated in the result. That I value will be updated in the result here. Okay, this will be linear time, this will be basically quadratic in nature, because you can see for one particular value we'll be iterating throughout the array. For one particular distance we'll be iterating throughout the array, and in the worst case we'll be running a loop. So max minus min time it will be running, so the overall complexity will be max minus min into the n value. Now, can we do it more optimally? Yes, we can do it more optimally using the binary search approach. How we can do it more optimally using the binary search approach? So the idea will be that we have the range. We know the lows and the highs. See, my low value is what here? Understand that the lowest distance will be 1 and the highest distance here will be equal to 8 here. I'll calculate the mid here. I'll calculate the mid. Now, what is my mid here? My mid is going to be nothing but, as of now, my mid is going to be 4 here. Now, basically, I will check that whether I can place the cows at 4 distance or not. Now understand one thing very carefully, like how binary search is going to help. So suppose that you have a particular mid that you have calculated. So you will try to check that can you maintain at least mid distance between the cows or not. At least mid distance between the adjacent cows or not. Suppose that if you cannot maintain at least mid distance, then what you will do? If this gives you false, if you cannot maintain, if you check for this mid distance and you cannot maintain at least mid distance between the adjacent cows, right, in that case you need to decrease your search space, right? In that case you will do what? In that case you will say that you will update your high as mid minus 1, because if you cannot keep the cows, if you cannot keep at least mid distance between the cows, then you cannot keep mid plus 1 distance, mid plus 2 distance. You need to search on the left side of mid, so that is why you need to update the high as mid minus 1. Otherwise, understand one thing, that if you can, suppose that if you check for this mid, okay, and it returns a true, if you can keep the cows at least mid distance away, if you can keep the adjacent cows at least mid distance away from each other, in that case you will store it as the result. You will store this mid as your result, but you will try to do what? You will try to find a higher value of mid, because you want to find the highest value. Now you want to maximize your minimum distance between adjacent cows. So what you will do is you will update the low as mid plus 1. It's just like a exam, or it's just like a college counseling. If you get in an IT, you will store it for yourself, but you will try to get IIT also in the next attempt. Correct. So you will try to search for something better. You will try to look for something better. So if I'm able to maintain at least mid distance between all the cows, adjacent cows, right? So I'll store it in my answer, but I'll try to maximize this. I'll try to maximize this minimum. So I'll try to search on the right side. So we'll update the low as mid plus 1 here. Now, in this particular case, what will happen in this question? If you see this particular question here, so my mid value will be 4. Now, you know that 4 is not going to be the answer, because I cannot maintain 4 distance for the cows, because you can see here, if I'll keep the C1 cow here, and then after that, I cannot keep C2 here. I cannot keep C2 here also. Then after this, where will I keep the C2? I'll keep C2 here. Then C3 will go out. So 4 is not going to be the answer. If I cannot keep the cow 4 distance away from each other at least, then I have to search on the left side, because if I cannot keep 4 distance away, I cannot keep 5 also, 6 also. So I have to discard my life. I have to discard my right half. If I check for the mid and I get false that I cannot place the cows at least mid distance away from each other, then I need to decrease my search space. So I need to search on the left side of my mid. Okay, so my high should be updated to what? If I get false, my high should be updated to mid minus 1. So now what will be my high value? My high will be mid minus 1. My mid was 4. Mid minus 1 will come out as what? Mid minus 1 will come out as 3 here. Now at this point, you calculate the mid again. What do you get? So this is when you get false, guys, as I said, if you're not able to place. Now what is my mid here? Mid is 2. Now can I place the cows at least 2 distance away from each other? You can understand that yes, I can. If you'll see, C1 will be here, C2 can be put here, and then C3 can be put here. So I can place the cows at least 2 distance away from each other. So in the result, I'll store this particular mid, that is, I'll store this particular guy 2 here, and I'll try to search for the like higher value. So I'll try to search, if I can place it mid distance away, I'll try to search that can I place it more than this mid distance away or not. So I'll try to search on the right side of this mid. So I'll update since I'm getting a true, so I'm storing this answer, but I'll update my low to what? Mid plus 1 here. So what will happen here is, now my low will get updated to 3 here. Now at this point we'll get the mid as 3 as well. Now will 3 satisfy as well? Yes, because you can see that this arrangement has got 3 distance away, and then C2 and C3 are also 3 distance away. So 3 also satisfies the criteria. So we'll update the result to this mid. So the result will be updated to 3 here. Now after this, what happens is, if you'll observe, So we'll update the low to mid plus 1 again. Now low will be updated to mid plus 1, that is 4. Now the low crosses the high, that is when we stop, because low is greater than high. So that is when we can stop here. Okay. So you can understand that for a particular mid, we are iterating throughout the array and checking, right? But the thing is that we are applying binary search here. So you can easily conclude that for one particular mid value, okay, for one particular mid value, we are iterating order of n times, because we are iterating throughout the array and checking whether we can put the cows, all the k cows, at least mid distance away from each other or not. Now, if you see here, for one particular mid, this is happening. But the thing is that if you see, we are applying binary search here. So that is why it will take like how many steps we are going to take? We are going to take log of max minus min steps. Correct. So it will be n into log of max minus min here. Okay. Now, if you see, check function is going to remain the same here as we used in the linear search approach, but we'll be applying binary search here. So you can see we'll be sorting the given sprawl array. Then after that, result is updated as 0 initially. Then low will be initially equal to 1, and the highest will be the difference between the maximum element and the minimum element of the array. Then we will iterate till the low is less than equal to the high. We'll calculate the mid here, and then after that we'll check that if we can keep the cows at least mid distance away from each other, and we can arrange them inside the stalls, all the k cows. Then we'll update the result with this mid, and we'll try to look for something better. So we'll update the low as mid plus 1 here. Otherwise, what we will do is we'll update the high as mid minus 1. Okay. If we cannot place the cows at least mid distance away from each other, then we need to search on the left side of mid. So high will be updated as mid minus 1. At the end, we'll be returning the result. And you can see here, the check function will do what? Initially, the first cow will be placed. So the counter will be 1, and it will be placed at the 0th stall. So previous will be updated to the position of the 0th stall. Then after this, we'll check that the ith stall that I am at minus the previous stall. If the distance between the ith stall and the previous stall, if it is greater or equal to the minimum that I'm considering, the mid that I'm considering, in that case, I can place the cow here. So I'll increase the counter, and now this particular ith stall will behave as my previous stall for the next iteration. So we'll update the previous as this particular stall, and if we can place at least k cows at this distance or more than k cows, then we'll return true here. So that is what we have done. So you can see that this will be the time complexity, that is n into log of max minus min here. Now let's try and submit this code as well. I hope you have understood the dry run clearly here. Let's try and submit this code now. So let's try and see whether the code gets accepted or not. It should get accepted, hopefully, because we have written it correctly. It is running. You can see that the code got accepted. I hope that you are clear with this question. Make sure to comment understood if you understood the explanation. If you understood the explanation clearly, make sure to comment understood as well. Thank you for watching this video.